switch over, and June is our new lead teacher. We use only volunteer teachers. June's our first paid teacher. And so she's going to take over, and I'm going to be the student, and we're going to go through some of the methods that she's developed. We're a nonprofit. We started in 2006, and we start teaching kids programming in the 5th grade, some as young as the 4th grade. We always need teachers, but we stopped calling them teachers because when I say we only use Java professionals. When we say teacher, you think about standing in front of a classroom with 30 kids. Okay, and that's not the way it works. So we started calling them mentors instead of teachers. And this is sort of typical. There's June. She's working with 2 or 3 kids. We usually have a second person, a helper in the room. So it's really sort of a personal kind of get along with the kids. We have levels of tests, and we have certificates we give out, 10 different levels. The robot competition, this was when we were at the fairgrounds. We're now at the Ruben 83 Science Center, and this was the, which event is that?
That is the Gold Rush.
This is the Gold Rush, where they all take off together. I think this is mostly the most exciting one, too. They're looking for a infrared beacon. They all start off together. There's obstacles in between. They bump into each other, and it takes 20, 30 minutes before somebody finally finds it. These are all autonomous. Most of the people using the Roombas hacked into with an interface board we developed. This last year, most everybody using Android phones. We modified, we used the SparkFun yo-yo board, and we modified the interface board so we can use Android phones, which is great because the kids learn how to use Android. We just moved into a new classroom, and I think I have one picture I'll show you. We try to get as many minority and disadvantaged kids as we got. June is particularly trying to work on getting women into the business. As you know, they're very underrepresented. Most of our funding comes from tuition. We charge tuition, scholarships, 25% of the kids. And just for background, second from the left on the top, that's me. I was a pilot in the Navy for 20 years, flew these things, P3s and P2s, and then I started some manufacturing companies of my own. None of you are old enough to remember this one, but this is a 6800 machine code trainer, and I made it for schools. We sold about 1,000 of them, so some of you older, there's no older guys in here, you might have used them in college. There's one of them up in the Computer Museum in Mountain View. I was making these things at the same time that Steve Jobs was doing his thing. I was going to the same meetings he was. I went to the Homebrew Computer Club up in Slack in Palo Alto. I never met him personally, but I'm sure we're in the same meetings. We bought 6502s, the 8-bit Motorola competition when they first came out. We were doing exactly the same things. I had an investor that stopped all the local small computer companies. He stopped at Apple. He says, 2 kids in a garage. He stopped at my company. He says, this is the most professional outfit. He invested in my company. Anyway.
Was that the right decision?
We built about 1,000 of these things. I could not envision a computer being used as a personal item for hobbies and things like that. I just couldn't see it. I saw it only being used for industrial and commercial purposes, and that's what I emphasized. I was wrong. This is the third company. This one here. I'll go back. Yeah. Our last company, Wintriss Engineering, we developed surface inspection equipment. These are line scan cameras we developed that scan in a line. They only can detect things that are moving, and this is a plastics assembly line. They call it a web line, where things move in a web like that. And we look for defects. We don't want that one. Did a golf launch monitoring system. This is the school we're at now, the Hacienda. Looks really corny from the outside, but inside it is absolutely beautiful. Reminds me of Stanford with the colonnaded passageways. It's just absolutely gorgeous. This is our old classroom. We only had 200 square feet. We got very, very crowded. Our students This is the new classroom. We've got 3 times as much space. We've got room for 2 classrooms at once. And this is going to be really, really great. It's one-on-one. This is the way you work. By the way, Stanley's a teacher. Paul's been a teacher. And June's a teacher. And Eric's a teacher.
Mentor.
Mentor. Yes. Thank you. That's what he's listening. This is typical in the old classroom. You can see how crowded it got. We had 8 people in a little 200 square foot room. This is one of our kids who's really precocious. Passed the Apple certification exam at 8 years old. No, 9 or 10 years old. He had to take the exam 4 or 5 times. They wouldn't allow him to take it here in San Diego. He was too young, so his mom took him up to Orange County to let him take the exam. And we use him at trade shows to show off the robot running around. I've tried, I really believe that we can do something with autistic kids. And we've had about 4 of them with various levels of success. This is one of the first ones, and it just didn't work. It depends on where they are on the Asperger's scale. This guy here was pretty high-functioning Asperger's. He's now at the University of Utah in their gaming program studying computer science. We had one of our students, I don't have a picture of him, passed the computer science exam in the 8th grade. So what we're doing is unique. As far as I know, there's no other school in the country that teaches Java to kids starting in the 5th grade. This is the Maze Care Fusion has been sponsoring a place. We were on a robo camp, a week-long camp ahead of the competition where we set up a maze and the kids practice running their robots autonomously through the maze. They were just studying. Just a quick aside, somebody heard we were in the robot business. He called me up and he said, I got a robot, 2 robots I want to donate to you.
That thing in the classroom as well.
There were these things here. And they were about $100,000 a piece. You know, I couldn't give them away. Finally, I got somebody in Thailand to buy them for $10,000, and it was a major problem getting them to Thailand. First of all, they wouldn't fit in an 8-foot thing, on and on, but we finally got $10,000 out. We got expansion ideas, things we need. This is a cute story here. It's the kids absolutely love what June is doing, what she's worked up with the school. This kid here is a scholarship kid, and he was sitting at home programming Java all day long, and his dad says, you've got to get outside and play. So they threw him out of the house. It was quiet, so we went out to see what was going on. He took a picture. The kid was writing a program on the sidewalk with chalk.
It's Python, but everything else.
Anyway, that's it. So it's up to June now, and I'm going to be a student.
Yeah, we're going to show a few of the practical things that we do with the kids, and Vic is going to be the kid, which isn't too far from his personality because he's a very large child.
I got to tell you, the way this thing got started was my last company, Wintriss Engineering, was started with 2 friends of mine, quote friends, partners. I went away on a business trip after the company had been involved for 20 years, and I came back and I'd been fired. And I didn't know what to do, so it was like a voice came out ahead and said, you're going to start a school teaching kids Java. I didn't even know Java, so I went to the UCSD Extension, signed up for a course, 4 course here, and guess who was my teacher? So everything I've learned from Paul, so if I make any mistakes tonight, it's his fault.
They don't pay teachers well enough at UCSD.
Really, how's your liability insurance?
It's all about the satisfaction. It's extremely, extremely satisfying. So I've been doing this for about 6 months, and before that I was a Java developer. I've spoken to you guys a few times about different projects that I was doing. So I was volunteering for like I took a kind of a career break, and I was volunteering teaching kids programming with these guys. You probably know Lynn Langett and Luana Falco. They do a lot of speaking around town. And so we started working on this project. I did some project management for them and volunteer teaching. And they used a sort of a thing built on top of Turtle, which originally came with Logo, to make some simple programs for kids so that they could see the output of their work really immediately. So Then 6 months into that, or then about 6 months ago, Stan sent a tweet that Wintriss was looking for a teacher, and I was like, well, I'm doing this for free anyway, maybe I'll just be a teacher for a while. And I taught Barbara over there a little bit, so it was kind of like on the radar. So what was in my head at the time was to take what Teaching Kids Programming have been doing and basically just start them off with that. It's expanded a lot since then. But we're going to start off with a demo of how the Teaching Kids Programming curriculum works. It's using Tortoise, and you can plug in there. You got to bring up the Google Docs. So we typically have about 4 kids per class, and that's 4 computers. At least 1 teacher. To have 2 is good. And so we try and focus on no classroom like lecture style stuff, no like me talking like I am now. That's one of the reasons I'm particularly bad at it, not a whole lot of practice. I try and make it so that they're coding pretty much all the time. So the classes are an hour and a half or 2 hours, and they code like from the minute they get in to when they leave. So they usually go onto the Google Docs where all the recipes are shared, and then they copy it from there.
We're going to process it.
No, we're going to do it in Eclipse. Vic and I have a few battles. One of the earlier ones was NetBeans versus Eclipse. Another one which hasn't been resolved, I'm kind of giving in on, is where the curly braces should go. But we're using Eclipse today. I don't know why you agreed to that.
That's good. The kids learn that it's like actual development stuff they learn. It's the curly battle brace.
Yeah, real job skills. So you need to start a new class. You use the little sleeves. And then just call it whatever you want. We're going to rename it now. And then paste what you have on top of that. This is how all classes start. We get the recipe from the Google Docs. Yeah, we just see. Oh, that's much better.
Yeah, is that good?
Yeah, awesome.
Everybody's dark. There's no way to like have a back on or something. I don't know. Okay. I guess we can
It's
see.
really hard to see the code if we don't do this. Okay, so scroll up to the top there. Can you minimize the console because there's not a whole lot of space. Rename the class file to become crazy with the code.
So what's the matter?
Can you maximize Eclipse? The green. Okay. Like that one.
Okay.
Yeah, and close the console. Bottom left. See the big white square that's doing nothing?
Oh.
Alright. So, can you actually do Command A and then Command V? Because got a little bit of the old stuff on. Command A. And then Command V.
So do you teach them actually what a IDE is? And what's actually going on?
Not theory, no. Pretty much,
Just
there's enough to teach them so that they know how to code, like even just the basics. So you start with the basics and then, work our way up to stuff like that, but we don't teach them like how stuff gets compiled. They understand roughly how Java works, like maybe after 6 months or so, but try and keep it as practical as possible. Not like no theory.
This is the right thing?
Yeah, so you gotta rename, use that bubble there. And then use the bubble to rename the file. Call it Panther. Just double click the top piece, the top option to rename. See the top options here? Can you save that there?
What?
Can you save it?
Save it?
Yeah.
You say.
Yeah, there it is, okay. Okay, why is that? Can you hover over the red and see what's up with it? I think it might have not liked that you pasted it from a text pad. There's little characters in there. Sorry guys, we really did practice this.
Yeah.
Using text
Maybe,
pads.
maybe if you
but
could just
not-
do the format, Control Shift F might get rid of it.
Try that.
Do what?
Smash it.
No, gotta delete, cause it's got some weird stuff.
Everybody shout suggestions.
Some little characters.
Yeah, right.
Next one.
And by the time we're done shouting, we'll be done fixing it.
Yeah. Open emails.
So, the way these recipes work,
Fix that with save.
do it and all.
Or,
So the way the recipes work, it's intentional. So the idea is that the kids like guide their own learning, so they have enough information here to write a small program by themselves, and they know the procedure because they do it like they do this like over and over in every class. They start with number 1. They run the code to see what they've got is working, and then they delete the comment. So we can start at number 1 there and see if you can complete that line. See number 1?
Where'd it go to?
It's left of it. Format, and you'll see it all in there.
There it is, okay.
Yeah.
Move the tortoise and fixes. So I think it's tortoise. Do we have
Yes.
command completion?
We should have command completion.
Right, check that?
No, control space. There you go.
Yes.
So this is the little tortoise thing. You'll see that it allows you to do some graphics. So he's going to move it 100 pixels. And then run that thing. There's the tortoise. Moved 100 pixels. You're good with that, so delete the line. And then go on to number 2.
Number 2, make a variable from number of pixels of size, number of sides.
It's actually surprisingly hard to get kids to understand what variables are when they're very young, like when they're 9 or 10. So we use these little boxes. You're doing that, Vic, yeah? You know how to make a variable? So
Did
Paul taught you that one? Yeah.
You didn't initialize it.
She didn't say
I
initialize
didn't,
it.
well, it's gonna be a pentagon. So how many sides is that? 6. No. Okay, so we use these little boxes to explain what variables are. I'm gonna pass them out. See, ints have little numbers inside and strings have little letters. And we name them to teach like swapping algorithms and things like that. We have lots of these little boxes.
So I can't test this, so I'm just gonna delete
Okay, that sounds good.
number 2, and go on to number 3.
Yeah, go to number 3.
Run the tortoise, 360 degrees, divide by number of sides. Okay, tortoise. Done.
Yeah. You're smart.
360. Divide by sides. Okay, shall I run that?
Yeah. Okay, is that working, you guys?
Looks like it.
Would you give them a pass? Is it turning 360 divided by 5?
Yeah.
Probably.
It's turning.
Okay,
Okay,
so I'm
they
gonna
say,
erase number
okay,
3.
yeah.
I'm gonna erase number 3, I did that successfully. Do everything below 200 times, that's what was confusing. What below, everything below here, right?
Yeah, the formatting got a bit lost. All the way down to number 7.
Well, FOR tab, control space.
Yes. See, this isn't so bad.
see the braces are in the wrong place.
Yes, we are.
I agree with the Vicks formula, that looks much nicer.
This is Vic's Eclipse.
Yeah.
Move the comments up in there too, actually move the
Not the
curly
sun
down.
guidelines.
Oh, it's the curly
Yeah,
down.
down there.
Looks like top there.
Where's it go? Down to here?
Down to under number 7.
Under number 7.
And while he's doing that, so kids learn at very different speeds and they code at very different speeds.
Some of us are slower than
That
others.
was not what I was talking about. But see the variation section on the bottom, that's like for the kids that are finished faster than the others. And so then they go on and do those optional tasks is to stop them like getting bored.
Okay, can I try that now?
Yeah, you should try that.
Do we have to wait on it goes 200 times?
Yep. I think, do you think his 4 looks okay? Java experts? They didn't see it.
200 to 199.
Speed it up.
Alright. So can I take out number 4 now?
Yes.
Yeah, number 4. Do number 5. Where's number 5? Make the total maximum speed.
Warp speed, Mr. Sulu.
So the kids don't know anything before they start this, except they've used turn and move to make a square, and that's all they know. They know that when they do tortoise dot, that there are some methods on there, and then they'll search through and try and find the one that's going to help them.
What's max speed?
It's 10. We're not going to have time to show the Java doc today, but they usually have a little window where they can see a description of what each
Can I
each
try
tortoise
this
method
now?
is. Yep.
You can
Now they use the password.
Okay, I can erase that now.
Yeah.
Number 6.
Move the tortoise, move I pixels instead of 100.
Okay.
Don't write a new line of code.
Make the, I put it 100, it was 200.
No, it's moving 100 now,
Oh,
and you
moving
want to move it I instead.
Okay.
So does anyone know what's going to happen?
Mm-hmm.
Yeah.
And the kids really get turned on. They just, oh, look at that.
Yeah, well it's designed so that they can make very small changes and then see the effect right away, because kids, or anyone really, don't have very long attention spans. So they can, they just have to hold it in their mind for a brief second, and then the tortoise is doing something different, and then they can see that they're able to change things.
Turn the tortoise 1 more degree. So turn the tortoise 1 more degree.
Do it in the command underneath number 7.
Okay. Right?
Yep.
Ooh, I like that.
You can make lots of spirograph things with tortoise turtle. And you can make lots, this isn't a particularly pretty one, but there are some.
So take that out. Is there anything else?
I think maybe you can change the color.
Change the color.
Maybe you can change it to a rounding color.
You're asking for a lot.
Set pen color.
Set pen
You have to get it from the color object.
Oh, that's right. Oh, you didn't teach me that part. That's right. I do good work.
Yeah, that's amazing, Vic. So that's a really basic example of what the Teaching Kids programming curriculum consists of. It's a lot of different recipes like that, maybe about 15 of those. And that's how we teach the kids when they come in first, and they don't really have to be very technical to be able to step through that stuff. And you can see how they can follow it themselves, so they don't require like full-time teacher supervision. We just tell them, we just recently got little traffic cones, so when they get stuck they put the little miniature traffic cone on top of their Mac, and then a teacher can come over and help them. But the idea is that they're able to run through these things themselves, so we can have big classes, so that they're motivated to do it by themselves. Alright, I'm going to go back to my slides. I'm not quite sure what's
I'm
next
not
on the
connected
plan.
to the internet, so.
Yeah, so like I was saying, this is intentional coding, which you probably heard Llewellyn talk about. It's like you write what you're gonna do in pseudocode, you complete the code, once you've done it, you delete the comment, and then you continue like that. And the learning is self-driven by the students. The reason it's pretty and it's a little tortoise like this is kind of cutesy and it's simple and it's all static methods on the tortoise because, you know, they kind of like those kinds of things. And you'll see, we're going to show you another recipe. I've developed more after that aren't tortoise-based. But what I usually do is try and make it something that they're interested in. So the next one we're going to show is a scary maze. And something, I don't know, like kids are absolutely crazy about zombies right now. They all watch The Walking Dead. They love Minecraft. And they always say YOLO. And they range from like 9 to 15, 16.
And watch The Walking Dead.
Yes.
Okay.
And they love, like, even when I've got a really boring thing to teach them, like something in an array list, and it's an array list of zombies, they're like, oh yeah, array list of zombies, right on. So just like spinning it in something that they're interested in works really well. And allowing them to personalize it, like have a picture of themselves or something that they like or their dog. And so you'll see in the next example we're going to do, I've templated, I've made a template, so all the code that's a little more difficult, like the swing stuff, is taken out, and they just follow the steps to complete the application and get something good to happen. So in the early stages, I think it's not too good to make them feel like programming is really hard. So like just to focus on some basic stuff until they get enough confidence to feel that they're able to build their own applications.
I can't get on the network, so we're gonna have to just do this.
Oh, that's good. Do you want me to read that? It might get messed up with the text editor, and that's going to be a pain because there's a lot of lines in this one. So we use Google Docs. That there's like an account logged into all the machines, and how I usually start a class is say, okay, we're going to do the recipe, and then they all go into Google Docs and they copy the thing down and they start it running by themselves. So that's what Vic is going to do.
You want a new?
And new class. It's not going to go in your project unless you change the source folder.
So I gotta do that. Where am I gonna do that?
It's better if you click on SD Jug and then right click and say new class, and new Jug. Oh, that doesn't look too bad at all.
So we just gotta change this. This little light bulb.
Yep.
Top one.
Yep, no, the third one. Can you format? Okay, so this is a little program, it's a maze. When they're using the mouse to navigate a little maze. When they hit on the edge, it's gonna make a scary noise and show a scary image, which guess what is probably gonna be a zombie, if it's any of the kids that I teach. But so the first thing that they do in this is they make their own maze, and that kind of lets them be a little bit creative. I think we prepared one that isn't so creative. Do we have like a maze?
I think it
Just
is.
run it and see if it will pop up. Okay, this is my maze. This is the starting point. It's supposed to be bigger so that they can move the mouse around, and then when they get to the red, when the pixel underneath the mouse gets to the red, then it's gonna say that you want nice. Theirs were far more complicated, and there's obstacles and shortcuts through it, and little cheats.
Take out the first one,
Yeah, that one's done already.
okay, set the mouse bar state, and then use it.
So if it's stuff they haven't seen before, like using the robot class, usually put that in there.
So we gotta guess at a couple of positions, right?
Yeah, so you wanna put the mouse in the reservoir part at the bottom where it's the big black circle. So now, at this point, like, the kids are learning about Cartesian coordinates. Well, it's not really Cartesian, but at least the way the coordinates are laid out on the screen. So they know, where's the mouse at?
Must have fallen off the screen.
Yeah, that's too much. So Vic's trying to get the mouse to go in the black reservoir, and his length was too much. Still too much, Vic?
Height there is only 400.
Oh, I just noticed that.
That's why they pay standard books.
This is true.
And they don't call them standard electronics.
There we go. Should go down a little bit more.
A lot more.
A lot more, okay.
Do 300.
Yeah.
Yeah.
Pretty good. Close enough.
Okay, just put in a few pixels to the right.
Oh, you pixels to the right.
Like 5.
Five.
Okay, it's not enough then. Don't trust me.
Just a wild guess, right?
Yeah. This is what it is.
All right.
Okay. Okay, so now we're ready for step
There we go.
for step 3.
Step 3. Add a mouse motionless.
Okay, do you know how to do that?
I don't know, we'll see. Tortoise?
No, you're obsessed with Tarzan.
Oh.
Just add the nice motion listener. It's a J panel, so we'll do that.
Oh, where's our Where's our
I didn't teach him tortoise.
You didn't add just do add nice motion listener. And in there put this art.
Oops.
And you're missing the mustache. So for the kids,
Where'd the mustache go?
there's-
Down?
you see, you keep saying mustache, but so curly braces are mustaches for us because if you turn it on its side, it looks like a mustache. And Vic has always told the kids that that brackets, braces, or what do you call them, parens? That's a mouth. So like, you know, there's this is in the mouth
You
right
got a
now.
mouth, you got a stomach, you got beginning of the stomach, end of the stomach, and stuff goes in the mouth, and they like what happens next. That's
Return statement at the end.
yeah.
Vic's anatomy.
Okay, so that doesn't test anything yet, does it?
I don't know, you might see something, we'll check it out anyway. So I think it teaches them good practice to continually run their code. And we teach them a lot of, like, starting when they're about a year in, we do unit testing.
So number 4 is next, where's number? Print the mouse color rate, let's see what color loss is. Is that true? So, mouse color. So
Yeah, you just have to print it out.
Alright, that's-
So do the kids get high school credit for this?
Too late to start.
No, they don't get credit, we're not accredited, but what does happen is they take the honors course, which gives them 5.0, and anybody who's been through our school gets a 5.0 in their honors course in computer science, so it just boosts
have 2 students at the moment studying for the Oracle certification, the Java Programmer 1, which is pretty cool. They're 15.
We had,
One's
Right.
16.
we had one kid pass computer science exam in AP in the 8th grade. I don't know if I said that already.
You're supposed to be
Oh.
programming.
Distracted.
The kids.
Okay, want me to run this? Color
Okay.
looks like it's coming in as some sort of a negative number. June, why is that a negative number?
Why is it so big? It's stock.
I think it's some sort of RGB code. I don't really know. Does anyone know what it is?
Well, you got 9 digits
So he's
there.
printing out the mouse color is the pixel that's underneath where the mouse pointer is.
It's probably a 4-byte value or something like that.
Yeah.
Yeah, the black is probably all F's.
RGB
Oh,
and alpha.
yeah.
I think it's RGB and then alpha.
But I like a sushi 0.
That's Alex.
Alpha is transparency.
Okay, so that one's working.
Yeah.
What's next? Now you're gonna hold the background color. So what do I call this, right? Background color?
Yeah. Paul, your audience has stolen my ints. Yeah, what do you think? Can you give me that back?
No throwing of the boxes across the.
Okay, should I test that?
Yeah,
Not gonna do anything
it's
else.
not gonna do anything else.
Alright,
But it's good that you're trying to test things all the time.
alright, I get points for that.
Yeah.
Okay, I can erase line number 5.
Yeah.
Mouse is touching, if the mouse call a scare method. You got a scare method down here? Yeah, there's scare.
So if the mouse is touching the background color, call the scare method. Now, do you guys know how to do that? This is,
What's if, just add?
yeah.
Okay, if the mouse is touching the background color. So, if the mouse color,
Yeah.
mouse color. Mouse color. Background color.
Yeah.
Braces.
That must be why it's red.
Go into the format.
You gotta initialize your background color.
Initialize.
Yeah, and you should set background color to the actual color of the background.
Oh,
And to find that out, you have to run it.
shoot. No.
Yeah.
The background color is, oh, just the background.
Well, black is 167777216, so just do when it's less than that, I think. So what we're trying to do is know when the mouse is outside of the black line.
You gonna remember that number for me?
No, can you copy it in there?
No, because.
I think those other numbers are gonna come up as greater than the.
That's exactly, yes, good point. So anything that's greater than that big number will be outside.
Who's gonna remember the big number
You
for
can
me?
just, you can copy it here.
No.
1637772.
Oh,
There it is.
there. Oh, but we don't want the negative one, right?
Yeah, you do,
You
The
do?
negative is part of that.
You want the negative in there?
Yeah, but it's not really the background color, it's now the line color, 'cause it's the black. part along, and then the if statement do the greater than.
What, I got an error up here, oh, that's right, I'm just, this, okay.
You need to change the green text there if the mouse is not touching the background color or something like that.
Yeah, well theirs has a solid background, just mine. That really bad little example there is not one color. But
You want-
theirs is usually a
you
dark
want less
color.
than?
Shouldn't that be not equal?
Yes, it should be when it's greater than.
Not equal.
Not equal or greater than,
But either should work,
alright, I tried.
yeah.
Ooh.
So boo
Good
is
sound.
printing out, and boo, that's the first line of the scare method. Are you gonna try and do it now? How steady is your hand?
Oh, you want me to do that?
Really? I thought that's what you were doing. Now, aren't you guys
Straight up.
really glad that you came out here tonight to watch me? It's okay, I think they get it.
Wasn't it supposed to play a sound?
Well, he hasn't gotten to that yet.
Oh, no.
No,
Okay.
now you're on
Those
number
who've seen the
7. Play the
previews.
sound for Stan.
Okay, number 7, play the sound, audio clip. We already got the sound in there.
Yeah, we do. You gotta
So
play
we
it though.
found-
So
we
number
found-
7 is done.
We found it, okay. We gotta play it, so I think we just say, yeah, sounds. Dot. Play.
Yeah. I always use the same format with noun and verb in the instruction, so they know from Tortoise that the verb is the thing that they're calling the method on, and the method is the verb, and they can use that. Our sound isn't ideal. It's got like a second delay at the start. Then they have like a scary image come up, and so they've learned like a bit of logic there, and it's kind of fun, and that's like an example of a very, very basic recipe that we would have them do. Most of them are a good bit more difficult than that, but you know, we were thinking about the audience. We didn't want to tax your rates. No, it would just take forever to do it. So, do you guys have any questions before we move on?
Let's see the scary image.
The scary image, we didn't record one, but all the computers at school have all this weird stuff all over them that they found. So I got this idea of the scary maze was from Aaron, and Aaron is making he does podcasts every Saturday. Do you guys know Aaron? He moved to San Francisco, but he used to be here. He used to be very active, and he was a teacher at our school. But he does a podcast, or like a video cast every Saturday called Build Something Awesome, and it's really awesome. And he's doing Android applications and lots of educational things on there. It's great. BuildSomethingAwesome.org, I think. Okay, let's see what's next. Okay, so teaching kids, the most interesting thing about it is the dynamics between them. And coming from an agile background, I've used a few agile techniques to try and motivate them. So peer competition works really well to get them motivated. A large majority of them are male, but I'm starting to believe that the whole philosophy about teaching girls, you know, foofy things is a lot of BS, because girls are just as competitive and just as interested in technical things as guys are at that age. I think it's just like that they're pushed into liking dolls or whatever. So it's pretty much works for all of them to add a little bit of competition. So a few techniques that we use. These are a little ghetto right now, but we use the perfection game. Is anyone familiar with the Core Protocols by McCarthy's? Nope. Alright, well, so a lot of the time we have the kids write on the board like code snippets or whatever for practice. And so then the rest of the class will sit and watch what the other kid's writing, and then they'll vote with these ghetto paper plates which have numbers on them. And so depending on the number is how much they think that the the person can improve what they wrote in order to make it perfect. So it gets them all engaged in whatever's going on at the board. These are numbered from 1 to 5, and then there's one that they really love. There's a fail card in here. Maybe I took it out because that was distracting. Sometimes we just use the perfection game. The way it works is, so if somebody does a performance or some sort of a, like say you make a document or just to provide, like make a work output, you vote between 1 and 10 for, you give the thing a rating, and the points that you need to make up to a 10 are all improvements. So like say you wanted to play the perfection game on our presentation tonight, you might say, okay, that's an 8, and then it could be a 9, or it could be brought up to 10 if the presenters weren't so condescending all the time, and if it was faster at typing, and then we would get a 10. So that's the perfection game, we use that a lot. This easy button used to drive me absolutely nuts, because when I get to the classroom, there are these everywhere. And so, but the kids really like them. They use they're used when they achieve something. They press the button, and that's kind of like a little bit of a positive reinforcement. But what I use them for now is when trying to coordinate a large group of kids coding at once. Is when I say, okay, when you get to a certain point, press the button, and they it makes them work harder because they want to be the first person to press the button. So that is the competitive aspect also. And I also use them for quizzes, like ask them questions, and then whoever has the answer first presses the button, and then they get to answer, and then they get points for it. We do this instant death thing, which is like I'll put some code up on the board with intentional errors in it. They each get a pen, and then to say there's 4 different kids, each person gets a chance to go and correct a mistake. And if they can't find one, then they're out. So it's instant death. So as soon as you can't find an error, then you're out. And they just really, really love that. And we have prizes for things, like a lot of astronaut ice cream goes out.
Oh, Stanley brought that, didn't you?
I brought that.
Oh, you brought that.
I can't believe you brought plates and we needed them in back room for pizza.
Well, you can have them, I mean, but it took me a long time to craft these numbers onto the plates, so you're going to have to reimburse me for that.
They're slightly used, I'm not sure how much.
Okay, so another thing is, like when we're deciding what we're going to work on, I'll pick a few topics and put them on the board, and then give each kid a pen, and they each get 2 votes to put their initials on whichever task they would like to do, whichever program they would like to write. And so I got that idea from Agile retrospectives with the little dots. So in Agile, if you want to vote for something, everyone gets 2 dots, and you put them on the 2 things you like. And so that's how they decide what they're going to work on. Then we do a good bit of pair programming, not always. In certain groups, much more randori or mob programming, where all the kids will be working on one piece of code. They all sit in a circle, and then every 2 minutes, we get up and switch who's the typer. So it goes in a circle, switch, and then a new person will be doing the typing, and all the rest of them are motivated to stay kind of engaged, because they're going to be up in a little while, and they have to be able to follow what's going on. And getting them to teach. So we've got a really successful mentoring program going on right now, where the older kids teach the younger kids for 1 hour a week. And so they just kind of do that away in the corner by themselves. And it's just, the results from that are incredible. I'm really starting to think that teachers are not very good at teaching kids. Either kids teach themselves or kids teach kids. That's the way that stuff gets into their heads. It's far more sticky in that form. So try to play that as much as possible. Sometimes I get the kids to, if some are ahead, I say, okay, this is what we're doing next. Learn about it online, watch this video, and then present it to the class when the rest of them have caught up. Okay, this is not very clear, but this is Logan. He's trying to find the errors in this little puzzle that I've put up there. He's in a class all by himself, so it wasn't instant death, but just so you can get an idea, that's the find the error thing that we do a lot. Just to try and get them used to reading code, because a lot of time they get attached to the quick fixes in Eclipse, and the way they don't really have to know the code very well, because they can control space a lot. And for later, for like the AP, they have to write code, so we'll do that. These guys are all competing So I'm asking them questions and getting them to write code on the board, and whoever's finished first gets a point. And whoever gets the most points gets this little astronaut ice cream. I think this video might. No. Alright, I have here. These three have been working together for a while.
No. It's called No. It's score. No. Score equals score plus prize money.
Okay, well, so those guys are working together, the three of them, and like, if there was a way to compare three people to an old married couple, that's what they're like. They've been in the class for like 8 months together, and the girl always knows all the answers, but she's kind of quiet about it, but they're fun. So that's them working in a tree group, and lots of the time they work in twos, lots of the time they work in groups.
When you get old, you get to work in a three groups.
Well, so if you guys are interested in checking it out on March 2nd, I think, I'll verify the date. Woody and his crew are coming to Agile San Diego to talk about what they do, which is mob programming. And there's about 8 to 10 developers work on one piece of code every day, all day. They do everything together. It's pretty amazing.
So what is the astronaut ice cream? Except the freeze dry.
Yes. It's kind of geeky and it's also tasty, so that's why.
I've had it years ago when I was.
This is TJ. He's 14 and he's mentoring William, who's 12. And this is a video also. Sorry for all the technical issues, guys.
Yeah, that. So basically, you have a for loop, and you make this int row, or I, or whatever you want to call it, and then you want to basically have it use 2D.length, and when you get the length of a 2D array, it's just the whole length of it, not the amount of numbers in it, like with just the normal. It's the number. Well, it's the number of columns, right? That's awesome. Wait. Oh, it's the number of rows. Okay, it's the number of rows.
Well, if you draw it this way, then it's
So that's Ryan teaching his classmates. He's, how old is he?
I think he's 7th grade now.
Probably
12,
12?
yeah.
He must be
Maybe 8th grade.
quite eight.
He's trying to explain
He's a
to
very
you.
smart kid.
Yeah, he has a blog called The Joy of Math. And the last post he had was like about the 4th dimension and how he's convinced that it's not time and all this stuff. Did you see that? Check that out. We're going to do a demo next to show how we use unit tests, but do you guys need a break? Are you kind of tired of looking at us coding up here?
Yeah, we need
Yeah.
a break to assist finishing these.
Okay, let's take a break then.
So 5-10 minute break, please. And don't forget the rest.